Okay, the second goal in 5.7 is find zeros. So when you're looking at a polynomial and it asks you to find all the zeros, ask yourself, when finding zeros, ask yourself if you can factor it. Can I factor? If you can factor it, you can solve it pretty quickly. Can I factor down to linear or quadratic factors? If you can solve or factor any polynomial down to quadratic and linear factors, you can find the zeros. You can always use the quadratic formula to solve the quadratic factors. Can I find integer zeros on the calculator? Well, if I can't factor something, maybe I want to start factoring it by finding a zero on the calculator, then taking that factor out. Can I find rational zeros? Now, you might not be able to find any integer zeros, but can you find rational zeros on the calculator? Any of these will help you find the zeros of a polynomial. So when you look at a problem like this one, first thing you ask, can I factor? It's 4 terms. It's looks like it factors by grouping. So I'm going to go ahead and try that. I'm going to group it out. And then I'm going to go ahead and try and finish it here. So x squared, x plus 2, plus 9, x plus 2. So my factors are x plus 2 and x squared plus 9. Okay, so this is h of x in factored form. So I know that my zeros are -2, and if I set this equal to 0 and solve, I get x squared equals -9, so I take the square root, x is equal to plus or minus 3i. So there are my 2 imaginary zeros and 1 real zero, which is a total of 3 zeros, which is what I'm looking for cubic. All right, so keep any of these techniques in mind, because if you can follow any of these, it's going to help you find the zeros. The key is to factor no matter what. Even if you find a zero on the calculator, factor that out and get it down. Okay, the second goal of this section, or the second part of the second goal, is called complex conjugates. And so this is kind of, we've already talked about complex conjugates when we were simplifying fractions with an imaginary number in the denominator, where you multiply the top and the bottom. So for example, if I had 5 over 1 plus I, I would multiply by 1 minus I, top and bottom. Okay, that's the reason you multiply is because these are complex conjugates. And then you would get something in the denominator that's not imaginary, and of course the numerator then becomes imaginary. All right, so that's kind of what complex conjugates are, and that's kind of the reason why we're doing this, is because then you know that you're going to get something that's not imaginary when you multiply them. So when you have one of these as a zero, a plus bi or a minus bi, when you have one of those as a zero, then you have to have the other one as a zero. That's why imaginary numbers come in pairs, okay? Because you have to have conjugates. Now, here's kind of a standard way of writing this problem. So don't let these instructions confuse you. It's pretty basic. It says write a polynomial function. Write a polynomial function of least degree. Of least degree with integral coefficients. Integral means integers. Integer coefficients having zeros that include. So basically all you're doing is writing a polynomial function that has those zeros. So the zeros of my polynomial function is -1, or -1, 1 plus 2i, but then because we have a complex, we need to have its complex conjugate. So 1 minus 2i. Okay, so these are the actual zeros that we're going to use to find the polynomial function. Now, anytime you have a zero, you put it into a factor. So I know the factors of my polynomial function are x plus 1 for this 0, x minus 1 plus 2i for this 0. You always subtract the 0. Here I subtracted -1, becomes a positive. But I'm always subtracting the zeros from x. And then 1 minus 2i. So these are my factors. I'm going to rewrite this because I don't want you to get confused that it's a plus, because it's not. It's minusing a -1. You're always subtracting the 0 from x in your factor. Now, to find the polynomial function, all you do is you multiply these. And there is a trick to this, but not really. So I'm going to go through and multiply this, but then I'm going to show you a different way of multiplying. Some of you will like the second way better, but it's a little more confusing. Okay, so I'm going to simplify this up. I know this one is x plus 1. I'm going to go ahead and distribute the negative. So I have x minus 1 minus 2i. Distribute this negative. I get x minus 1 plus 2i. Okay, so there's my three factors. I am going to multiply these two together first. I'm going to take the answer of that and I'm going to multiply it by x plus 1. Okay, so let's go ahead and do that. So when I multiply these together, I multiply all three of these terms by all three of these. So I end up with x squared minus x plus 2xi, and then I'm going to take -1 times all three, minus x plus 1 minus 2i, and then I'm going to take -2i times all of those, negative 2xi plus 2i minus 4i squared. Okay, so basically what I'm going to do, I'm going to translate this up. Okay, so I basically took all three of these times all three of these. I'm going to go ahead and add like terms. I'm going to bring it up here. X squared is by itself because there is no other x squared. I've got negative x, and that's it. So that's negative 2x. 2xi minus 2xi cancel. They add up to 0. 2i and negative 2i cancel. Negative 4i squared becomes plus 4. So then I have a plus 1 and a plus 4, which is plus 5. So these two multiply to be this trinomial. But then I'm going to take this trinomial times x plus 1, and I end up with x cubed plus x squared minus 2x squared minus 2x plus 5x plus 5. So my answer is x cubed minus x squared plus 3x plus 5. And there's my polynomial that has those three zeros. Okay, so that's the basic way of doing it. You just distribute the negative first, and then you just FOIL or multiply each one together. That's probably the easiest way of doing it, but it's a little bit longer than doing it this other way that I'm going to show you. If I were you, I would just do it this way. But if you like to go do things a little bit differently, here is another way of multiplying those two factors. Okay, so let's kind of start right here. I know I've got those three zeros. So that means I've got three factors, x plus 1, x minus 1 plus 2i, and x minus 1 minus 2i. Okay, so I'm basically starting right here. This time, I am going to still distribute. So I have x minus 1 plus, or minus 2i, and x minus 1 plus 2i. Okay, so I haven't done anything different yet. Now, do you remember when we multiplied difference of two squares, we were at a minus b times a plus b? When you multiply those, you get a squared minus b squared. Okay? Well, that's basically what I have. I have a, which is x minus 1, minus 2i, and a plus 2i, or x minus 1 plus 2i. So this is like my a, this is like my b. So this is the same as x minus 1 squared minus 2i squared. Just like a squared minus b squared. So this, if I FOIL it, is x squared minus 2x plus 1. This ends up to be minus 4i squared, which is plus 4. And that's basically that. And then, of course, I would multiply those together, just like I did here, and I would get my same answer. So that is a way of multiplying these two factors together. That's a little bit easier. I shouldn't say easier, it's a little faster, but a little more tricky. You have to understand difference of two squares first. All right, that is how you do the rest of section 5-7. Good luck, let me know if you need help.